It was. Good. What was it like?
Empty.
No.
We just sat out on the deck
Hmm.
and I sipped, nursed a glass of wine. We didn't want to say anything.
Yep.
And ate some clam chowder and a club sandwich. A grilled chicken. I'm kind of tired. Can I really go?
Good. Enjoy that.
I love you. You have time? Your talk is so good.
Yeah, it was fun. Okay, so how do I think about composite functions? First, I have to realize that we're being asked to take one function and another function and put them together in a certain way. Now, when you're just doing transformations, you might add them together or you might do something different. But with composite functions, you can think of it kind of like multiplying. So what you're really doing is you're taking one function and you are compositing. So if you've ever done with like epoxies where there's like part A and part B and you mix them together and then it's like super strong glue or whatever, you take part A and part B and you mix them together. And if part B is on the outside, it's important because if you have part A and part B, it's very different than part B and part A, right? So those two things are different. So when you look at a function, really basic one, like f of x equals x squared, that means every time you see this function, you know that the x is going to get squared. So if you are now compositing a function in there, so you have f of g of x, you need to replace everywhere you see an x with g of x. So now what you have is f of g of x equals g of x squared, right? So now you have one function, g of x, inside another function, f of x. That's the composite function. Now, since I love analogies and I was part of the car industry for a long time, this is also a way to think about composite functions. If your primary function, so in our case, f of x, if f of x is the big trailer, your g of x could be a truck, could be a car, could be a van, doesn't really matter, right? G of x is what we don't know. We know that g of x is going to go inside f of x. And then that whole combination is off and doing its own thing. So you can think about composite functions as one function going inside another to create a new whole thing down the road. So if you want to go back to our original example, aha, fancy paper. We had f of x turning into f of g of x. We had x squared turning into g of x squared. You can make the same thing and say, well, what does f of a car look like? F of a car looks like the function of the car equals the car squared, right? So I want you to think about the functions not in terms of like pure math terms, but think about it in terms of one function going inside the other, and order matters because again, A over B different than B over A. So we want to keep that in mind. And now thinking about the problem, we know what f of x equals. We also know what f of g of x equals. What we want is g of x. So the only way we can get that, what we need is we need to solve for g of x. Now, if I wrote that down a different way, it would look like this. We know f of x, and we know that it turns into f of g of x. What we have to figure out is what we plug in that g of x value, what we plug into f of x that makes it turn into this. So two ways to think about it. If you think about composites as kind of like multiplying things together in a specific order, you can think about dividing out g of x. So look at this side of the equation, what you know of f of g of x, and think about how you'd pull out an equation, pull out a function to get back to f of x. So that's working backwards, if you will. The other way to think about it is to go forwards and think about what values of g of x, what function g of x might be that you can guesstimate. You can guess it, plug it in, try it out, see if you get the right answer. Depending on the complexity of the problem, one way might make more sense than the other. And depending on how you think about it, one way might make more sense for you. This is how I think of the problem. And so my plan of attack was to look at what I had, f of x, look at what we also have, f of g of x, and think about how to solve that g of x that we don't know, and then use that to do g of x in the last step. Okay, that's the plan of attack. See if you can give it a go.